Hi lovely people, my name is Richard and welcome to my channel. Today our discussion will be on logarithms. Today before the video ends, we'll learn how to apply the laws of logarithm and the properties of logarithm to solve some problems. So we say if we have log s base a plus log y base a, it will be equal to log sy base a. Then if we have log s base a minus log y base a, it will be equal to log x over y base a. The same way if you have log s exponent n base a, it will be equal to n log s base a. Then this one, which is called change of base, if you have log b base a, it will be equal to log b base c over log a base c. Also, if we have log a base a, that's a log to the same base, is 1 and log 1 is 0. Please, if you want to know the reason why all this is like this, check my videos on YouTube. So today before the video ends, we'll learn how to apply all the laws and the properties to solve problems. So come with me. So solve our first question. It says simplify log 32 base 2 times log 81 base 2 all over log 243 base 2 times log 16 base 2. So what we need to do is that we change all the log, or we write all these numbers in an index form. So what will we have? We'll have the first one log 2. See, 2 exponent 5 is 32. So we say 2, we change the 32 to 2 exponent 5 times log 3 exponent 4 is 81. We say the 81 is 3 exponent 4 all over log 2. Then 3 exponent 5 is 243 times log 2. Then 2 exponent 4 is 16. So what do we do now? We apply the third law. The third law, we can drop off the exponent if you remember that. So we say this will be equal to 5 log 2 base 2 times 4 log 3 base 2 over, this will be 5 log 3 base 2, then times 4 log 2 base 2. Now remember, a log to the same base is 1. So we can say this is 1. Another log to the same base here is 1. So we can say this will be 5 times 1. This is 1. Then times 4 log 3 base 2 over 5 log 3 base 2, then times. So let me say times. So this one too, a log to the same base is 1. So we say 4 times 1. Look at this. We have log 3 base 2. It can divide this log 3 base 2. So what will be left? So we said this can divide that. What will be left there is 4, and here 5. So we say we have 5 times 4 over 5 times 4. 5 times 4, 20. Over this 5 times 4, 20. 20 divided by 20 is nothing but 1. So we can say that log 32 base 2 times log 81 base 2 all over log 243 base 2 times log 16 base 2 is equal to 1. I hope you get that. So our second question is evaluate log 8 base 2 plus log 16 base 2 minus 4 log 2 base 2 all over log 16 base 4. Please pause the video and try solving. So how do we solve this? We have to write the logs into index form, those that are not in index form. And the base of the index must take the base of the log here. So we say this will be log 2 exponent 3 base 2. See, 2 exponent 3 is 8. plus log, then 2 exponent 4, log 2 exponent 4 base 2. 60 is 2 exponent 4 minus 4 log 2 base 2. All over this will be log 4 exponent 2 base 2. 4 exponent 2 is 16. What do? We apply the third law by dropping off all the exponents. So we have 3 for this, 3 log 2 base 2 plus 4 log 2 base 2, then minus 4 log 2 base 2. All over this will be 2 log 4 base 4. So remember, a log to the same base is 1. So this log 2 base 2 is 1. This is 1. This is also 1. Then this is 1. So we have 3 times 1 plus 4 times 1 minus 4 times 1 all over 2 times 1. So 3 times 1, 3 plus 4 minus 4 all over 2. 4 minus 4 is 0. So we have 3 out of 2. Then we can say this is nothing but 3 out of 2. I hope you have the same answer. Now our third question, a very interesting one. They say we should evaluate 1 over 3 log 27 base 5 plus 1 over 2 log 25 base 5 plus 4 log 5 base 5 plus 3 over 2 log 4 over 9 base 5 plus 3 log 3 base 5 minus log 3 base 5, then minus 3 log 10 base 5. A very long one, but very, very easy. Now what we'll do is that let's deal with these fractions here first. So we change this to index forms. So we have 1 over 3 log 3 exponent 3 is 27. So 3 exponent 3 base 5 plus 1 over 2 log 5 exponent 2 is 25 base 5 plus 4 log 5 base 5. Please, I know this is 1, but let's hold on. Plus 3 over 2 log base 5. We can change this to 2 over 3 all square. See, 2 square is 4 and 3 square is 9. Then plus 3 log 3 base 5 minus log 3 base 5 minus 3 log 10 base 5. So now we apply the third law. We drop this off to multiply. So we have 1 over 3 times 3 log 3 base 5 plus 1 over 2 times 2 log 5 base 5 plus 4 log 5 base 5, then plus we drop off this 3 over 2 times 2 log 2 over 3 base 5, then plus 3 log 3 base 5 minus log 3 base 5 minus 3 log 10 base 5. I hope you are getting it. So if 1/3 multiply 3, it will be 1. So we will left with log 3 base 5 there. Then the same way to half multiply 2, it will be 1. So we left with log 5 base 5. Then plus 4 log 5 base 5. Then plus 3 over 2 times 2, it will be 3. So we have 3 log 2 over 3 base 5, then plus 3 log 3 base 5 minus log 3 base 5 minus 3 log 10 base 5. Now we apply the laws here again. Let me write this very well. We apply the laws for those that are not having a coefficient of 1. Like they have a distinct multiplying. We bring them off to come and square the logs. So we have log 3 base 5. This one is 1, so we don't have problem there. Then we have log 5 base 5 then plus this will become log 5 exponent 4 base 5, then plus log 2/3 exponent 3 base 5, then this also will be log 3 exponent 3, this will go there, base 5, then minus log 3 base 5 minus log 10 exponent 3 base 5. You see, we are reducing them one by one. Now let's simplify this. So we have log 3 base 5 plus log 5 base 5, then plus 5 exponent 4. 5 exponent 4 will be 625, then plus log, this will be 2 cube is 8 and 3 cube is 27, so 8/27 base 5, then plus log 3 exponent 3 is 27 base 5, then minus log 3 base 5, then minus log 10 exponent 3 will be 1000 base 5. I hope you get that. Okay, so please, before I apply the laws, there is a subtraction. I want to factor out that to make our work easier. So I'll repeat this: log 3 base 5 plus log 5 base 5 plus log 625 base 5 plus log 8/27 base 5, then plus log 27 base 5, then minus out, we'll have log 3 base 5, then this will be plus log 1000 base 5. I hope you understand that, please. Remember, one of the laws of logarithm is saying when they are adding with the same base, we repeat the base. That's the first law. We repeat the base and multiply the logs. So we can rewrite this thing, this long thing, as log base 5 bracket. See, 3 times this 5 times 625 times 8/27 times 27 for this long thing. Then minus bracket. Since this one too is adding, we can say repeat one of the base log. So log 3 times 1000 base 5. Now what do we do? We see this 27 can divide that 27. What's left? We left with log 3 times 5 times 6, 25 times 8 base 5. Then minus log 3 times 1000 will be 3000 base 5. So this was our last step. So if we multiply 3 by 5 by 625 by 8, we'll get 75,000. So we have log 75,000 base 5 minus log 3000 base 5. So we apply the second law. They are subtracted with the same base. What do? We repeat one of the base, then they divide. So we have log base 5, 75,000 divided by 3000. This will be nothing but 75/3 base 5. The zeros will divide. 75 divided by 3 is 25. So you have log 25 base 5. So you can change 25 to have a base of 5. This will be equal to log 5 exponent 2 base 5. We can drop off this to have 2 log 5 base 5. See, a log to the same base is 1. So So we say the whole of that is 1. So we have 2 times 1, and the answer is 2. So we can say that the answer to this our question is nothing but 2. Very, very interesting. So I'll be very happy. Try this, and please leave your answer in my comment box. That's log 8 base 2 plus log 625 base 25 minus log 256 base 16. Please try it and leave your answers in my comment box. So the next thing we'll talk about is logarithms involving substitution. So when we talk of logarithms involving substitution, it is a situation where the value of some logs will be given to you for you to evaluate another log. How do you do that? You use the base and the values of the logs given to you to find the value of that particular log. So look at it. It's given that log 2 base 10 is equal to 0.301. Then log 3 base 10 is equal to 0.477. Evaluate log 6 base 10, log 5 base 10, then log 3 whole number 1 over 3 base 10 without using calculator or table. So the instruction is very strict. You shouldn't use calculator, because if you point this in the calculator, you'll get the answer. But the values of some logs are given to you for you to use it to find the value of another. So let's go. So ask yourself, what can you do to these 2, the 3 and the base, okay, to get this particular log? Any of them. So you see that when you multiply 2 by 3, you get 6. So you can say our log 6 base 10 can be equal to log 2 times 3 base 10. 2 times 3 is 6. I hope you get that. So remember, when logs are multiplying, we can split them. So we have this can be written as log 2 base 10 plus log 3 base 10. I hope you get that. See, log 2 base 10 is 0.3. So we can say 0.301. Then log 3 base 10 is 0.477. If you add this, then we can determine that our log 6 base 10 is 0.778 if you add these two. So we are able to find the value of log 6 base 10 without using calculator. I hope you get that. So let's solve the second one. B. We want to evaluate log 5 base 10 without using a calculator. Look at it. When I divide 10 by 2, I'll get 5. Then I can rewrite this log 5 base 10 as being equal to log base 10 over 2. So 10 divided by 2 is 5. So if logs are divided, we can subtract. So we have, this will be log 10 base 10 minus log 2 base 10. I hope you get that. Now log 10 base 10, a log to the same base is 1. Then minus our log 2 base 10 was given to us to be 0.301. Now when we subtract 1 from, so 1.000 minus 0.301. When we subtract that, what do we get? We get 9 and 9. Then this is 6 points. So we get 0.699. Then we can say that our log 5 base 10 is 0.699. I hope you get that. So the third one, now we are going to evaluate log 3 whole number 1 over 3 base 10. So please, we need to first change this. So this is in mixed numbers. We change it to improper fraction. So 3 times 3 is 9 plus 1 will be 10. So this will be log 10 over 3 base 10. So we can rewrite this, since they are divided, as log 10 base 10 minus log 3 base 10. Now a log to the same base is nothing but 1. Then minus a log 3 base 10 was given to be 0.477. So we subtract that. 1.000 minus 0.477. So this will be 3, 2, 5.0. So that will be 0.523. Then we can say that log 3 whole number 1 over 3 base 10 will be equal to 0.523. I hope you get the same answer. So our second question says that given that log a base 2 is equal to 3 and log b base 2 is equal to negative 2 and log c base 2 is 5, we should evaluate log 8, the square root of a exponent 5 times b over c exponent 3 base 2. So how do we solve that? Look at it. This and this is multiplying. So we apply the second law and split them off. So we have that will be log 8 base 2 plus log the square root of a exponent 5b over c cube base 2. I hope you get that. See, we said the square root of every number is that number exponent half. So we can rewrite this as 2 exponent 3 is 8. Then this as log a exponent 5b over c exponent 3 all exponent half, the square root. So we apply the third law now and drop the exponent. So we have this will be 3 log 2 base 2, then plus this will be half log a exponent 5b over c cube. Now look at this. This and this is multiplying with the same base 2. So what we do? We can add this, and this is dividing. We can subtract using the second and the third law. So we can say, we know that log to the same base is 1. So we have, this will be log 2 base 2 plus half bracket. The half is multiplying everything. We have log a exponent 5 base 2 plus log b base 2. Then we have minus log c exponent 3 base 2. So we can apply the law, the third law, by dropping this. We have 3 log 2 base 2 plus half bracket 5 log a base 2 plus log 5 base 2 minus, we drop off the exponent 3 log c base 2. Now with this, now we know that log 2 base 2 is 1. See, log a base 2 is given to be 3. Log b base 2 is given to be negative 2. And log c base 2 is given to be 5. We just substitute them, then we evaluate our expression. So now let's substitute. So we know that log 2 base 2 is 1. So this will be 3 times 1 plus half bracket 5. Log a base 2 is 3. So times 3 plus log b base 2 is negative 2. So plus negative 2. Then minus 3. Log c base 2 is 5. So 5. So what do we have? This will be 3 plus half bracket 5 times 3, 15, minus 2 minus 15. 3 times 5 is 15. So 15 minus this 15 will be 0. So we have 3 plus half bracket negative 2. Half of negative 2 is negative 1. So 3 minus 1. And this will be 2. So we can say that this is nothing but 2. I hope you get that. Please, we'll end it here today. Remember to subscribe to my YouTube channel and click on the notification bell. Please share my videos and comment. Your comments keeps me going. Check out my videos on logarithms that involve simultaneous equations as well as linear equations. Until we meet again, bye-bye.